Looks like time for Tech Talk Tuesday. Let's see if I can get a sound check and a video check. Can you see me? Hey, Alan. All right. There's a few people, Matt, Bo. Hey, y'all. Thanks for watching. I'm going to pray that I get enough service here in the man cave that we can, that I can keep this going. Hey, Ron, Alan, Tom, James. Hey, y'all. Thanks for checking in. I appreciate you looking. Let's see what else I got here. Ed, Archie, yep, Tom, all good. You can hear me good. Okay, James, Ron, my buddy Ron. Got Shovelhead. Got a nice Shovelhead. One day when I retire, hey, Irv. Man, you're supposed to be working, man. And Ricky, Greg. So if you guys are working and you're clocked in, don't tell your boss you're watching me because he'll get mad at me. So y'all need to keep this on the down low and don't let everybody know that I'm taking you away from your work. Or you can use it as a continuing education style position in your job. Hey, Donald. Mark. Hey, Mark. Good, champ. How you doing, Donald and Charles? Mark. Howdy. Hey, look, I just wanted to tell you that now that I am officially certified, I am YouTube certified mechanic now. So I just want to let y'all know this will prove it. That's supposed to be funny. Don't get mad. A lot of people worked hard to get something like this, but we had those made. Hey, Graham. Mike, I just wanted to tell you guys that I am in Tennessee. This is the man cave. I worked for 41 years to put this together. I'll show you around in a few minutes when I get a little bit of a crowd signed up. Hey, Chuck. Hey, Ian, I wanted to tell you guys that this is my first try away from either at my shop in Americus, Georgia, or on the highway traveling. So this is Tech Talk number 99. 99, wow. 99 of these in a row. Thank you all for watching. That's great for everybody to check in. Hey, Steve, Daniel. So hey, Chase and Larry, I want to see, where is my buddy, Charles? Charles, if Charles doesn't show up here, we need to call 911 because he hadn't missed one yet. Hey, John. You know, it's the wrong time of day for some folks. I get it. I get it's the wrong time of day. And I know that some folks are working. Some people just don't get here in time. But I'm going to tell you, Rob, Jackie is going to record this. This is live right this minute, live. But when Jackie records this, hey, Jamie, we will be able to save it and put it on YouTube tomorrow. JC, what's up, man? I appreciate you guys checking in. This is Tech Talk number 99. Charlie, there you are. I'm glad you made it, man, because I was going to have to stop the video on my phone and call 911 and tell them to go to your house. I'm just kidding. It's so great to see you come on here every time. I'm thankful. There's Brian and Steve. I appreciate you guys. So look, I was going to tell you a little bit about the retirement thing. Everybody on here, I see a lot of old guys on here, and I see a lot of young guys, and I want to tell you that I started off as a teenager working on engines and trying to learn how to go fast. And back in Florence, South Carolina, there was a guy there named Slick Johnson that worked at the Honest Charlie Speed Shop, and he showed me how to do valve jobs and boring and honing, hey, Lon, and how to balance and blueprint engines. Now, blueprint has changed because back in the day when we would blueprint an engine, balance and blueprint, we would make all the parts weigh the same and put it on a machine and spin it up and try and come up with some crank balance factor around 50, 49, 51% for the reciprocating bob weights onto the rotating mass and try and come up with some math that would make the engine not shake. Hey, Bryce, Bradford. But this guy named Slick Johnson taught me how to do that stuff, and then when we decided to move away from Florence and open our own place down in Americus, Georgia in 1979, it was a great time for us to try and come up with some money and buy some machines and stuff. And Charles Israel from Americus, Georgia, and I teamed up, and we were able to go to Sumter Bank and Trust and borrow some money, SB&T, to buy machines. And we made payments on these machines forever. I think Jackie and I have almost all the machines paid off. Hey, Jackie and Chad. And I promise y'all one day when all this crazy family issues we got going on at home here is over and Jackie gets back to normal or her sane self, she's going to come on here one day with me and tell a story. So Let's promise that. And Jackie, I'm speaking for you, honey. I'm sorry. Hey, GB, what's up? Aaron. But when I ran that engine shop deal and learned how to do it, we ended up with so many employees and so many people been through. 87 and different employees have been through Star Racing over 41 years. Great people, learned a lot, taught a lot, learned a lot, taught a lot. And Jackie and I paid our way through all the mistakes that were made by all of us because there wasn't a book. There wasn't a book. You couldn't go online. There was no internet. There was no cell phone. The internet for us was the public library when we opened up. I mean, you had to go downtown to the public library and you had to look through the card index and find a book that you might have wanted, or you may have heard of it or a friend told you, but there was no place to advertise that stuff. I don't even know how people knew about things back then. But there were some Hot Rod magazine, Carcraft magazine, Popular Hot Rodding, posted stories and advertisements about these books, and we would go get them. But look, the books were written 50, 60 years ago, and so many things have changed. Some of the math is still the same, like bore times stroke times 0.7854 times number of cylinders equals cubic inches. That math is still the same. But what was said in the book 50 or 60 years ago was you need this size bore based on this head, and you need this size stroke based on these cubic inches. And it taught us a lot. But our engine designs and engine ideas have changed dramatically over the years. We've migrated to larger bores, bigger valves, taller cylinder heads. The engine configuration has changed dramatically over the decades. Been very fortunate to be in this engine building industry for decades. I didn't invent this stuff, y'all. I read it in a book when I was a kid. Jackie got the books. We read the books. We built our first Kawasaki 900 back in 1973 using the Climber manual or the Chilton's manual or whatever it was we had to get in order to do it. I couldn't understand what it meant, but somebody was smart enough to write a book on how to build those things. And then, of course, I took the heads and cylinders and pistons over to Honest Charlie Speed Shop and had Slick Johnson show me what was wrong in his opinion with the valve job and the boring and the hone and the balancing and what needed to be light and what needed to be heavy. And we learned a lot and went fast. We set records, we won races, we traveled around America running in the IDBA and I think it was called, oh my goodness, NMRA, something like that. It was before we had Harley drag racing series and stuff. But everybody raced together, all the brands. But since that's happened, we got into pro stock. Once we met, we kind of went as high as we could in each category, and we wanted to get into pro stock because starting in the middle 80s, pro stock motorcycle at NHRA events started to get some traction, started to get some acclaim. And in order for us to grow our business and expand our capabilities on engine building in the normally aspirated genre, that was what my passion is turbos are awesome, superchargers, nitrous, I love all that stuff. But listen, if you can make one go really fast without a turbo, make one go really fast without nitrous, and if you can make one go really fast without a supercharger, then I believe that you have a really good understanding of how the pump works and what needs to be changed in order to put that stuff. Now, I'm not an expert on turbos. I'm not an expert on superchargers or nitrous. I know a lot about it because I was fortunate to learn a lot about engines. So I just wanted to tell you that. Another thing I wanted to share with you guys is these are my opinions based on the things that I think I learned because I blew up a lot of stuff. I ran over a lot of crankshafts. I ran over a lot of pistons, connecting rods. I ran over a lot of heads and cams. I'm talking about run over, like they fall on the ground and you drive over it. And when you drive over enough stuff, you get scared, you fall down, you get hurt, and then you got to learn how to keep from running over parts. Then when you buy a dyno, that's really big trouble. I was telling a friend of mine, Lake Speed, today, we were running a Suzuki on the dyno, and I read in a book that it said we needed to know where peak torque was. I had horsepower curves, and we were gearing and shifting based on horsepower, and somebody in a book or on the internet said you need to know where peak torque is. Well, the torque curve and the horsepower curve always cross at 5,200, 52 RPM because that's the math, and I've been over that like 100 times already. Well, number 99. I've been over it now 99 times. But why we wanted to know where peak torque was, I had no idea, but I read it in a book. So we got on the dyno and we started chasing this peak torque, and we would floor it. The horsepower would go over, we'd print out the numbers, and then I'd look and I'd say, wow, peak torque is still the first number on the page. So we would load the water, more water to pull the motor down lower, floor it, go again, and now we'd be down around 8,000 RPM, winding up to 12,000. And I said, wow, the peak torque is still the first number to the left of the dyno sheet. So we put more water to it and dynoed until we found that peak torque was so far to the left of the dyno sheet. Left of the dyno sheet. It was so far to the left that the engine was trembling. I mean, the connecting rods had to look like little toothpicks trembling when I would go full throttle with an engine that turns 12,000 RPM and try and find peak torque. And if it had been, say, 6,000 RPM, we kept chasing left by load, load, load. And what you don't want to do on any engine that I know on here is to put it in high gear and floor it and find out how much stress the engine can take. Now that works pretty good on diesel engines, I guess, and some that are built with the most massive connecting rods, big, giant, thick blocks, massive pistons that are made to handle tremendous cylinder pressure, and wrist pins that look like straight pipe with a little hole drilled in it. And then those engines are made for big, high stress like that. Let me put some lube in here. This is 0 weight. I got to put a little bit on the pipes. Hang on one second. I tried that one time with 3-weight oil and it made me cough a lot. But anyway, the 0 weight works when you got the dry pipes going. Back to the torque. So I was at full throttle on the dyno. We had a Stuska, and we were loading it with water, and we were recording the torque needle with a tachometer, and we were doing the math. Torque times RPM divided by 52 equal the horsepower. And I was trying to get the torque needle to go as far as I could. It was a Toledo scale giant torque gauge on the dyno. And what we found was when you get peak torque at whatever RPM it was, might have been 5,000 or 6,000, but I saw with my own eyes, I'm looking at the engine running and it's trembling. And it's trembling. And it said, pow! And that fast, right out of number 3 hole, right out the front of the case, I saw a bright white flash go across the room, and it changed colors dramatically, and when it hit the wall, it was black. And I had to stop. I cut the power off, I cut the dyno off, and I had to think, what was that? What was that? The connecting rod was so overloaded, and it had seized up to the crankshaft on the big end, and it was glowing almost white, almost bright yellow. And it blew through the front of the engine, and it, in about a 5-foot span of maximum velocity, it went from bright white to black. It went white, bright yellow, orange, dark red, black, and it hit the wall, and it was on the floor, and you couldn't touch it. It was on the floor smoking. It was a connecting rod. We blew the rod out by loading it down to where we outran the oil capability and the pressure capability of the main bearings and the rod bearings and destroyed the engine. Over time, I learned not to chase that rainbow. I want to chase that rainbow, which is on my dyno sheet. It's over here, and the RPM is over here, and we go fast over here. Now, if your street bike or this car right here, this El Camino right here, it loves power at 2,000, 3,000. And my Harley over here loves power at 2,000, 3,000. That's why, as Harley-Davidson fans and street car fans, we are big fans of torque. Torque is a number that measures more than horsepower below 5,200 RPM. I know that's another day, right? All right, I'm going to flip the screen over and show you the shop. Let's see if I can get this to look better without making everybody sick. All right, I want to show you that we put a 4-post lift in. I got the El Camino in here where I can tinker with it, and I've really enjoyed working on that. And I've got, these are the 5 Wallies I have here from Indy when we won the U.S. Nationals over time. That was kind of cool. And then up here I have some different ones. My friend Mike from Americas brought me a truck and trailer load of parts and pieces from my shop in Americas, and he said there's still 20 Wallies there. Here's a few of them, and the European Championship trophy and a Winston Invitational trophy. And then here's Buck in the shop to get a little work done. I'm really proud of Buck. He's exceeded horsepower per cubic inch on something that I'm going to be able to ride on the highway. And then this is the Road Glide Special that is all stock. I have finally cleared 500 miles on it, so it's in for a fluid change, and I'm going to talk to you about that. And then these are some of the Winston Championship trophies. that I've just got kind of stashed in here right now. But this is the front room of my man cave, and I hope to eventually put pieces and stuff that we've collected over our years in here to have a little bit of a place to tinker with my stuff. All right, the table says that we have Tech Talk number 99, and I'm going to do a little bit of an opinion here of the steps that we take when we're working on an engine. I'm going to leave that where you can look at it a second. I'm going to grab a stool. Okay. So when we are asked to develop an engine or get involved in an engine project, the most important thing we found over the time is ring seal. How big of a bore can we get in it, which dictates how big a valve we can put in it, which you got to be able to control those valves, so you got to really come up with a cool idea on valve train, and then the stroke. Now, airflow didn't really make 1, 2, 3, 4, 5. Airflow didn't really make the top 5. It's probably number 6 or 7. And that is, if the port is the right size, it's the right shape, and the valves have a really nice, like here's an intake port for the Monster Pro Stock head. If it's got the right shape to it, and in the right cross-sectional area to get the trapping and the speed of the engine squared away, this can flow 300, 400, 200, 100, whatever the flow bench says it flows. That's just a number. But in reality, even if it flows a lot and it's the wrong size, even if it flows a lot and it's the wrong shape, even if it flows a lot, that doesn't mean it's going to go really, really fast. And I'm going to tell you a really crazy story that Ron and I did in Americas on our Suzuki Pro Stock engine. And this is crazy, but we had one of these, and we were flowing it, and it flowed a lot of air. So we came up with this idea that it needed a bigger, more of a short turn radius. So the port, this is just crude rough drawing. So the port looked like this. Okay, can you guys see this? All right, so this is a small radius right here. And on a flow bench, since it's run at really low pressure, like 10, 15, 20, 28 inches of depression, which is the amount of pressure that the flow bench creates on this side of the port, and God's atmosphere pushes on this side of the port, and you really want to transfer as much of this barometer, 2992, 14.7 atmosphere, to go in when this valve opens. And the flow bench does it one time every minute or every 10 minutes or every whatever. So we see the air flowing in our head. We see this air coming in like this, and it's going over this, and we're measuring velocity, and we're measuring cross-sectional area and all this cool stuff. But in what is really happening in here when this is running at 10,000 RPM is the air is going in and out of here 100 times a second. And you've got just a nanosecond for it to take a gulp of air, shut the valve, squeeze it, light it, bang it, make a power stroke, open the valve, kick it back out the exhaust, and then suck it back in, squeeze it, light it, bang it, push it back out again. You do that 100 times a second. So the flow bench is a good tool, but it doesn't make the top 7 or 8 here. In my world, not your world. Flow bench guys that have flow benches and sell cylinder heads, they're really, really good, and they add tons to this, but this is my opinion, not yours, okay? And I'm going to explain it to you why. That's my opinion. So Ron and I were on the flow bench, and we were flowing at 10 inches of depression, and we found out that if we put modeling clay in here, and we made this look like this, and we filled this in with clay, we found out that it would increase the flow dramatically. So we took this small radius, and we made it a giant radius. And the air on the flow bench running at 1 mile an hour enjoyed making this turn. In reality, it's running like 500 or 400 miles an hour, and it's going in and out. So the flow bench taught us this. So we got this really nice epoxy called, I think it was called AB epoxy. And no, it wasn't. It was a marine repair. It's made to go Let's see what it was called. Somebody knows. Who's watching that can tell me what that stuff's called? Cop Coat, I think. It's made for repairing docks and ships and things underwater. It's a really cool product. But anyway, we made a really nice port with that epoxy, and it machined almost like aluminum, and it would stay in there while you'd run down the track. Now, did it go fast? Yes, it went fast. But we had the engine, one of these that was running on the dyno. It made 300 horsepower, and we filled this in with giant epoxy. Z-Spar, that's a good one. We filled this in with a lot of epoxy, and we filled this floor and made it a giant radius where at low pressure, low flow bench pressure, one time every 5 minutes, it would go in there and turn perfectly. Splash coat, yeah, Brolite, all those cool things. That's good. Thank you all for that, for bringing that in. But what we ended up with was a really slow turning port that worked good on the flow bench. Now, hey, from Indy. So we put it on the dyno, and it made 250 horsepower. And we were so disappointed because we had gained 50 CFM on the flow bench. And we went from 300 horsepower to 250, so we lost it. And so we took the engine apart. We thought the crankshaft had seized up. Wrist pins, pistons, valve springs. We worked on the engine, put it back together, and we could not get 300 again. We were stuck around 250, 260. So I said, Ron, let's try something. Get a vacuum cleaner, and let's go pull the carburetors off and get in there with the porting tool and go around the corner all you can and grind some of that epoxy out of there. And I would hold the flow bench. My vacuum cleaner is about the same as a flow bench. But anyway, I would hold the vacuum cleaner on there and let it pull all the shavings out that Ron was grinding with the porting tool. And we put it back together, and it picked up 10 horsepower. So we said, okay, well, let's do all 4 of them. So he got in there. I opened the carburetors, and we took the spark plugs out, and we blow air hose in the spark plug holes and put a vacuum cleaner right here. And Ron would go in there and grind. And he went over the turn. He went over the turn with a bit as much as he could with the engine on the dyno, with the cams, valves, everything in it. And he got almost all of it out. Guess what? It made 300 horsepower again. Put it back on the flow bench. It was down 50 horse. So we learned that day that it has to flow good. And I would say the record-setting head flows good. But if you look at this picture right here, somebody typed it in a minute ago, this cross-sectional area was so tiny that you can't measure that on the flow bench. It doesn't care. The flow bench doesn't put enough depression on this end to find this restriction. Now you say, well, I got a big flow bench. Mine will flow 50 inches. It really is a good flow bench. There are flow benches out there. The one I just sold was a 50-inch 1020 flow bench. It's a really great flow bench. But what that does is that speeds this up, and it shows you a little bit more, but it still can send you down the wrong road. So don't get married to the flow bench. That's the word I use. It's wrong. It's got quotations on it. Don't get married to the flow bench. Put it where it belongs. What's your top 10 things that matter in engine design? It's definitely got to move air. But it doesn't matter how good it flows air or how good the flow bench is or how good the head is. If you don't have any ring seal, you're not making any power. Bore size dictates the valve size. Valve size dictates how much engine air can come in and out of the engine and fuel. The valve train, you got to be able to buzz it high enough to get away from peak torque over here and go for peak horsepower over here on your dyno sheet. The stroke, the only reason we need stroke, in George's opinion, is whatever the rule says. The rule says you can have 500 cubic inches. You buy the block, you bore it out as big as you can, like 4.735, and then you get a calculator out and you do the math, and the math says I'm going to need 3.51 stroke to get 499 cubic inches. That's what you do. You put the bore in it first, put the biggest valves that will fit in the bore, then you do the math to figure out the biggest stroke to keep from going over the cubic inch limit of the class that you're running. Now, I wrote this over here on the side. Let's see, 10, 20, 25, 30, rod length. Rod length makes the top 30 or top 35, in my opinion. Rod length is what's left. And I know we went over that last week, and I just wanted to tell you about it again. Somebody give me, since I don't have a clock or a watch here, all I got is this clock I'm talking on. What is the current time where you are right now, y'all? Tell me that, please. Somebody hook me up. All right, that's 5, 10, 15, 20, 25. I'm not done yet. Come on. Time. 6:25. Awesome. Okay. Now, back in the day, a cool cam when we were kids were driving around the drive-in and driving around the place where you go to get your fountain drinks and your ice cream and stuff. We used to say a 3/4 cam was the coolest thing, and we didn't know any better. We would just hear a car come by and it had that lope to it. It'd go cha-cha-cha-cha-cha-cha. That was a 3/4 cam. That's what we called it, a 3/4 race. That means it's not a full race, it's not a half race, it's a 3/4 race. So for your Milwaukee 8 today, I know you've heard of them and seen them, but this is a real. If you've never seen one in person, here's a real 3/4 cam, and we sell them for the new Harleys. I just wanted to get that grin out of you. Just give me a grin, and then I want to tell you the compensators, which keep the crankshaft from beating the drivetrain to death. They make this part at Harley that's really brittle, and it breaks these. So we make one out of EN36. It's a super tough crankshaft type, billet crankshaft type material to hold up. I want to let you know that we sell those too. And Charlie, good job. Thank y'all, Eric, and I am so thankful for you guys clocking in and checking in with me, and I want to tell y'all thanks for that, and I'm going to switch back to me for a minute so I can tell you bye. There you go. All right. Thanks for tuning in. Come see me again. Next week, you guys, will be Tech Talk number 100. That'll be a milestone for us. And, of course, 104 will be 2 years. Hallelujah. Thank y'all. May God bless. Take care of each other. Pray for Jackie. Her daddy died yesterday. He's old. We've been taking care of him, and he finally got the most mileage he could out of himself, and he's moved on to home now. But I want to just tell y'all to pray for Jackie and her family because they're really having a tough time right now. So I just wanted to tell y'all that. May God bless y'all. Good night, and have a great time.